Now, sewer materials. First one is brick, as till now I was explaining. So these are few of the materials that can be used as a sewer material. Next we have concrete. So this may be a plain cement concrete, that is PCC, or a reinforced cement concrete. Next we have vitrified clay. Next we have asbestos cement. We have iron or steel. We have plastic pipes, and then we have glass fiber reinforced plastic pipes. So let us see in detail about these each of the sewer materials along with their working advantages and disadvantages. Brick sewer. This material is used for construction of large size combined sewers or particularly for stormwater drains. The pipes are plastered from outside to avoid entry of roots and groundwater through the brick joints. So basically where you can apply these brick sewers is whenever the size of that sewer is quite large. Okay, whenever the size of the sewer is large, at that point of time you can arrange these bricks in a suitable way to give a proper curvature. So if the size of that sewer is small, you cannot use the brick sewers, obviously, because of the practical difficulties. Along with that, what they said is the outside of this sewer will be plastered so that the entry of water, okay, entry that is infiltration of water, can be avoided. Plus one more difficulty, what usually practical difficulty what will be faced is usually on top of this we will be putting up the soil. At that point of time, if any of the trees are there, so those roots might enter into your sewer lines. Okay, so that's why this plastering will prevent both of these infiltration as well as action of root on that sewer line. So that's why that will be there. And one care that should be taken over here is there should not be much of a leak, because already since brick is susceptible to absorption, so proper precaution needs to be taken for this. And also they have said key most of the time it will be used for storm water drains, that is for runoff water. So in runoff water, as I said, no, there will not be much of a impurities which will be there, so only that water will get absorbed basically. But if the same thing is there with the sewers, then in due course of time the quality of these bricks, yeah, so that itself may deteriorate, and because of which the entire sewer pipeline may collapse, because continuously when the these bricks will start to absorb the contaminants. Okay, so because there will be formation of n number of acids, foul gases which will be there, so each of them will have a detrimental effect on the bricks material. So even inside there will be few precautionary coatings that will be there, but long term, okay, because these once these drainage pipes are put on, so for decades together these will not be disturbed. So at that point of time, whenever we say brick sewers, so that is mostly used for stormwater drains and for a larger section of pipe that can be used. Okay, now the next one what we have is, yeah, plain cement concrete or reinforced cement concrete. So plain cement concrete, usually we have that proportion of 1 is to 1.5 is to 3 for general typical usage of a sewer material which will be there. And these pipes will be available up to 0.45 meter of diameter, and reinforcement cement pipes are available up to 1.8 meter in diameter. So the plane, that is PCC, will be of 0.45 meter diameter, whereas for RCC pipes it will be up to 1.8 meter in diameter. So let us see in the next slide what are the advantages and disadvantages of this cement concrete pipes. Advantages: strong in tension as well as in compression. So if it is a reinforced RCC pipe, so then it will be strong in tension as well as in compression. Resistance to erosion and abrasion. So since concrete is quite a durable material and it has a wide variety of applications, so even we can say, or we can take a guarantee that so the amount of erosion or abrasion that is going to take place on the inside will be limited. They can be made of any desired strength. So based on the different mixed proportions that we are going to have, so different strength of material can be casted, and in turn that can be laid as a sewer material. So these can be easily molded and can be in situ or precast pipe. So easily molded in the sense what, we'll be usually having that based on the diameter of that pipe, we'll be having those particular molds through in which your reinforcement bars will be first put up, and then the concrete will be laid. So after a particular period of time, that can be used after a proper curing, so that can be used as a pipe material. So here in situ in the sense, if the sections are quite large, so at that point of time you can cast those pipelines in the site itself, so that is in situ, or precast pipes. So where if you have a same set of diameter that is maintained for a long duration, long length of periods, so at that point of time you can have precast pipes. Economical for medium to large sizes. So when you compare it with the other types of materials that we are going to use, so it is much more economical for medium and large sizes. These pipes are available in wide range of size, and the trench can be opened and backfilled rapidly during the maintenance of sewers. So these pipes are available in wide range of sizes, that is we can have different diameters of these sections made based on the requirements, okay. And in case of any maintenance that is required, so the digging of that backfilled soil as well as again refilling it will not take much of a difficulty, because already the strength of this material is quite enough to handle all the changes in pressure which will be there. Disadvantages: these pipes cannot get corroded, can get corroded and pitted by the action of H2SO4. So that is, so one major issue that we found out here is since we have reinforcement over here, so over a period of time, if the reinforcements get exposed to the sewer, or sewage, at that point of time the acid forms during the flow of that sewage can affect the these reinforcement and ultimately get corroded. The carrying capacity of these pipe reduces with time because of corrosion. So again, if the what I can say, these acids are in contact with the reinforcements, then definitely that particular difficulty is going to exist, where the erosion is going to take place, and in turn the carrying capacity is going to get reduced. Next, we have the pipes are susceptible to erosion by sewage containing silt or grit. The pipes are susceptible to erosion by sewage containing silt or grit. So any inorganic material which is going to be there, so that can act as a in a long duration of time, basically that can act as a eroding material for this particular concrete pipes. Petrified clay or stoneware sewers. These pipes are used for house connection as well as lateral sewers. The size of the pipe available is 5 centimeters to 30 centimeters internal diameter with a length of 0.9 to 1.2 meters. So vitrified clay or stoneware sewers are nothing but what, your polished clay which is going to be there, okay. So this can be used as a house connection. So if you have visited any of the newly constructed house which is going to be there, so even at that point of time for drainages, so usually the upper portion where the pipes will be visible, that will be of PVC in nature, okay. But whenever it enters into your ground and then it is passed, right, so for most of the time we still prefer these vitrified or clay pipes. The reason being what, these are quite more resistant and longevity is more when you compare it with the PVC one, okay. And the diameter of this will vary from 5 to 30 centimeters and the length will vary from 0.9 to 1.2 meters. So advantages of this: these are resistant to corrosion, hence fit for carrying polluted water such as sewage. Interior surface is smooth and usually hydraulically efficient. The pipes are highly impervious because of the coating or polishing that we are going to have, so it will be quite impervious. Strong in compression, so it is going to take a lot of compressive forces. These pipes are durable and economical for small diameters. Okay, these pipes are durable and economical for only small diameters. The pipe material does not absorb water more than 5% of their own weight when immersed in water for 24 hours. So this is quite a what I can say good or else less amount of absorption that is going to be there. So because of that polishing, so not more than 5% of the self bed will be absorbed by the material. So basically that particular absorption is less and can be used for various purposes, as whether it is in the house connection or for the lateral sewer in the connection system. Disadvantages: it is heavy, bulky, and brittle, and hence difficult to transport. So the only difficulty over here is, even though in advantages we have mentioned it as strong in compression, okay, but it is not strong in tensile forces. So it is basically a brittle material. So if you put a uniformly distributed load, it will take up. But if a point load is added, and that too at a rapid pace, so at that point of time it is going to get cracked up. So that's why it is a brittle, and hence it is difficult to transport. So during the transportation, even there is any not proper maintenance or means what I can say, stacking of these particular materials, because of the what I can say, the disturbances that will be caused during the transportation, these materials can get damaged. These pipes cannot be used as a pressure pipes because they are weak in tension. So as I said, so there is no reinforcement. Basically, these are nothing but the pipes made up of clay, but with a proper coating on top of this. So that's why here the flow cannot be under pressure. So it cannot handle the internal pressure of the sewage. So usually it will be a partial flow that will be there. These require large number of joints as the individual pipe length is small. So you can check out, it is only 0.9 meter to 1.2 meter. So whenever you think of the lateral sewer connection, so at that point of time the length will be more. So that's why we need to have more quantity or else more number of joints that needs to be added for this. Okay, so best example, if I just need to draw, I hope you might have seen some pipe something like this. On one end it will be broad and again it will be short. So this will be made up of your clay material. Okay, so you might have seen such kind of what I can say, pipes laying around the drainage systems, or if the municipality is doing, or even for a newly constructed house. So these will be quite more resistance for household drainage to work out with. Next is asbestos cement sewers. These are manufactured from a mixture of asbestos fibers, silica, and cement. Asbestos fibers are thoroughly mixed with cement to act as a reinforcement. These pipes are available in sizes from 10 to 100 centimeters internal diameter and length up to 4 meters. These pipes can be easily assembled without skilled labor with the help of a special coupling called the ring type coupling or a simplex joint. So here you can see these asbestos cement sewers which are there. Basically what you are adding these fibers into your cement and you are trying to prepare that particular pipe. So the sizes available will be 10 to 100 centimeter in diameter and the length will be up to 4 meter. Okay, and these can be easily jointed. One can be jointed with another one with the help of this ring tie coupling or a simplex joint, what we are going to study further. The pipe and joints are resistant to corrosion and the joints are flexible to permit 120-degree deflection of curved line. So here one advantage is what? These are quite resistant to corrosion, first thing. Second thing is, and joints are flexible. So they will give us a rotation or else a degree of deflection in laying of 120 degrees. So whenever you want to curve that particular sewer at a quite drastic angle, so that point of time this kind of sewer material will be helpful to us. These pipes are used for vertical transport of water. For example, transport of rainwater from the roofs in multi-storied buildings, for transport of sewage to grounds, and for transport of less foul sewage, that is wastewater from the kitchen and bathroom. So these pipes are used for vertical transport of water. For example, again, transportation of rainwater from roofs in multi-storied buildings, for transportation of sewage to the grounds, and for transport of less foul sewage, that is wastewater from the kitchen and bathroom. So for these particular asbestos cement sewers are preferable. Advantages: These pipes are light in weight and hence easy to carry and transport, easy to cut and assemble without skilled labor. So you can check out the major advantage is what they are light in weight and hence the carrying as well as transportation is quite easy. Plus even the assembly of this particular pipe with another is quite easy. Interior is smooth, hence can make excellent hydraulically efficient sewer. So what it indicates is since the interior of that particular pipeline is quite smooth, here we have this Manning's coefficient N as 0.011, so which is quite less when you compare it with the other materials. So here the resistance to the flow will be very less, and in turn the hydraulic efficiency of these sewers will be quite high. So it basically indicates what your head loss is going to be very minimum. Next we have disadvantages. These pipes are structurally not very strong. Okay, so these pipes are structurally not very strong. It will not be like a RCC pipes. Okay, because the reinforcement what we are having is asbestos fibers. So that will sort of add like a reinforcement, but they will not have that particular strength when I compare it with the RCC pipes. These are susceptible to corrosion by sulfuric acid. When bacteria produce H2S in presence of water, H2SO4 can be formed, leading to the corrosion of the pipe material. So here you can check out again, since a part of this is again cement material that we are going to use. So here also, because of that anaerobic degradation, partial degradation, right? So bacteria can produce this hydrogen sulfide gas, and hydrogen sulfide gas will react with the water present in the sewage to form what your H2SO4, that is hydrogen sulfide sulfuric acid, and because of this what will happen, the corrosion of pipe material may take place. Next is cast iron sewers. These pipes are stronger and capable to withstand greater tensile, compressive as well as bending stresses. However, these are quite costly. So as I mentioned, so cast iron sewers, so these are, cast iron is nothing but a metal, right? So these are quite capable of handling greater tensile as well as compressive forces, since it is a metal, as well as it can handle even the bending stress if it is applied. But the only difficulty will be these are quite costly. These are also suitable for sewers under heavy traffic load, such as sewers below railways and highways. So since they have a lot of compressive as well as tensile strength in them, so we can use them under heavy traffic loads also. They form 100% leak-proof sewers line to avoid groundwater contamination. They are less resistant to corrosion, hence generally lined from inside with cement, concrete, coal tar, paint, epoxy, etc. So here you can check out. So with a proper working, we can produce a sewer line which is 100% impervious, okay, or else it is leak proof. And here, as they said, they are less resistant to corrosion. So they can get easily corroded if they come in contact with the acid. So that's why they are generally inside covered with cement concrete or coal tar paint or any of the epoxy paints. Next is steel pipe. So these are used under the situations such as pressure main sewers, underwater crossings, bridge crossings, necessary connections for pumping stations, laying of pipes over the self-supporting spans, railway crossing, etc. So you can check out all these circumstances what has been listed over here. So already you know steel, right? So steel is a much advanced version of your iron, right? So it can have its molecular structure customized based on the requirement. Okay, so the amount of compressive as well as tensile strength that it can hold, even the durability of this which is there, so that will be much more than the cast iron what we have seen above. So that's why though this steel pipe, so even though it will be costly, but these can be used for these particular conditions where you require quite a strong material of sewer. Next, they can withstand internal pressure, impact load and vibrations much better than CI pipes. They are more ductile and can withstand water hammer pressure better. Since they are stainless steel or steel pipes, so they can basically withstand even the internal pressure as well as the impact load, which is not available for the cast iron. Okay, and even the vibrations can be much better handled than the CI pipes, that is cast iron pipes, and even they are more ductile and can withstand water hammer pressure for better. So whether it is an internal or external pressure that can be exerted on a sewer pipeline, if it is made up of steel, it can withhold both the things. Okay, plastic sewers or PVC pipes. Plastic is a recent material used for sewer pipes. These are used for internal drainage works in house. These are available in sizes 75 to 315 mm external diameter and used in drainage works. They offer smooth internal surface. The additional disadvantage they offer are resistant to corrosion, light weight of pipe, economical in laying, jointing and maintenance. The pipe is tough and rigid and easy to in fabrication and transport of these pipes. So everyone knows about the PVC pipes. Okay, so for internal house drainage as well as the external visible part of that particular drainage can be done effectively with the PVC pipes. So the diameter will vary from 75 to 315 mm. Apart from that, apart from that, basically these provide a quite a smooth internal surface, so even the hydraulic efficiency of this is quite high. And apart from that, these are resistant to corrosion, lightweight in pipe and economical in laying and jointing, so even for maintenance it will be quite effective. So that's why we prefer these PVC pipes for a small scale work, that is whether it is a residential building or an apartment. So the smaller quantum of sewage that can be managed, that will be much more effective by the PVC pipes. Glass fiber reinforced plastic pipes. So this material is widely used where corrosion resistant pipes are required. Glass fibers reinforced plastic can be used as a lining material for the conventional pipes to protect from internal and external corrosion. Glass fiber reinforced plastic can be used as a lining material for conventional pipes to protect them from internal and external corrosion. So the other materials what we have used, so it can act in conjunction with them to provide a better material. It is made from the composite matrix of glass fiber, polyester resin and fillers. Okay, so this is basically, this is like a glass fiber. I hope you know the properties, right? So this will be quite light in its nature. So these are plastic pipes but with some reinforcements, smaller fibers that will be added, glass fibers will be added to that. These pipes have better strength, durability, high strength, tensile strength, low density and high corrosion resistance. So when I compare it with the plastic pipes, these are the basic advantages of these. Glass reinforced plastic pipes represent the ideal solution for transport of any kind of water, chemicals, effluent and sewage, because they combine the advantage of corrosion resistance with a mechanical strength which can be compared with the steel pipes. Okay. So I'll repeat this sentence. Glass reinforced plastic pipes represent ideal solution for transport of any kind of water. So that inside that liquid can be water or it can be chemicals or it can be industrial effluent or it can be a sewage, because they combine advantages of corrosion resistance with mechanical strength which can be compared with the steel pipe. So you can check out. So all these advantages can be compared with a steel pipe, but here the weight is less as well as it can be easily transported and laid. Okay, so this will become the much more what I can say frequently used or modern material that can be used for a sewer material. Now next is shape of the sewers. So till now we have studied with respect to the materials that we are going to use for the or else selection of material for the construction of sewer lines. Okay, now let us see the shapes of these sewers. Okay, sewers are generally circular pipes laid below the ground level, sloping continuously towards the outfall. So what does this sentence indicate is, uh, basically, since this sewers, here the flow will be through the gravity only. Okay, there will not be a pressurized flow. So that's why you cannot have the sewer pipeline laid in this way, where the sewer will be going against the gravity. No, it is not possible. So whenever you lay the sewers and design that particular layout, you should make sure that from the source or point of source till the point of disposal, the elevation should always reduce. Okay, the elevation should always reduce, because the flow here will be through gravity only. These are designs to flow under gravity. As I said, shapes other than the circular are also used. So conventional one is basically circular. Okay, apart from that, we have standard egg shaped sewer. First one, new egg shaped sewer. We have horseshoe shaped sewer. We have parabolic shaped sewer. We have semi elliptical sections of sewer. We have rectangular shape. We have U shaped. We have semicircular shaped, and we have basket handle shaped sewer. So basically, what these why do we need so many shapes of sewers? Okay, so first of all, based on the particular type of conditions that are going to exist in the field, so if you change the shape of the sewer from this conventional circular one to any of these, okay, so it will provide the respective advantages. Okay, and even a simple example, if I need to tell you with respect to this, imagine I have a rectangular sewer along with a circular sewer. Okay, and one more I have is standard egg shaped. Okay, so let us call this. Okay, we have one more sewer, something of this size. So whenever I backfill the soil on top of these sewers, okay, so you only can imagine the maximum pressure will be there on this rectangular, since it has a flat surface area. Next, the second amount of load that will be there will be for the sewers, because here the surface area exposed to that particular backfill will be more. But whenever I consider this third one, that is egg shaped one, so that point of time what will happen is, since it is having this egg shape, so the maximum amount of load will be transferred to the side. Okay, so here this will be having, or else the strength of this, or else the capacity of this particular shape in handling the backfilled load will be much more when you compare it with the conventional circular one. So that's why here, like this, for each of the sewer shape will be decided based on the requirements. Okay, so that each of these sections in photographs we'll just check out in the next slide. Standard egg-shaped sewers are also called as ovoid-shaped sewers, and new and modified egg-shaped sewers are used in combined sewers. These sewers can generate self-cleansing velocity during the dry weather flow. So now you can check out why this egg-shaped sewers are preferred is, even during the low flowing season, that is your dry weather flow, when there is no runoff, at that point of time the self-cleaning velocity will be maintained. So what do you mean by this self-cleaning velocity? Let us just check out that. Imagine I have a sewer something like this. Okay, fine. So right now check out the conditions which is there. So for combined sewer, so in combined sewer what will happen, all your sewage plus runoff will flow through the same pipe. So usually these combined sewers will have more larger size. Okay, so in this larger size, during this dry weather flow, only the sewage will be flowing. Okay, during dry weather flow in combined sewer system, only the sewage will be flowing. At that point of time, conventionally what will happen for a circular pipeline, okay, so these particular sediments which are there, because of the less flow and lesser velocity, these are going to settle down at the bottom. And once these settle at the bottom, what will happen? The anaerobic decomposition will start, and in turn your foul gas of hydrogen sulfide will be generated over here. So we don't want such circumstances to happen. So that's why this self cleaning velocity indicates what? here this egg-shaped sievers will make sure that even during the dry weather flow, that is even during a very less flow of water, these sewer shapes will make sure that none of the settlement of these sediments will take place. Okay, so self-cleaning velocity is nothing but what? It is the minimum velocity that needs to be maintained in a sewer line so that none of the suspended particles will be settled at the bottom. Okay, I'll repeat my sentence. So self-cleaning velocity is nothing but the minimum velocity that needs to be maintained inside a sewer pipeline so that the settlement of these suspended particles can be avoided. Okay, so that's why the egg-shaped sewers are much more preferable in a certain set of conditions, that is combined sewers in dry flow, so that time they can have their self-cleaning velocity maintained over there. Now the next one is horseshoe-shaped sewer or semicircular sections. These are used for large sewers with heavy discharge, such as trunk or outfall sewers. Okay, so what do you mean by this trunk or outfall sewers? So usually how the sewage will flow into your or else through this system is basically with respect to whenever the sewage is generated in your house, so the amount of sewage generated will be quite less. So imagine I have these kind of houses. Okay, so each house will generate a fixed quantity of small amount of sewage. Okay, so that's why the pipelines what will be coming out will be of smaller section. Okay, but whenever such houses together combined and these collection pipes are made, so basically here we'll have laterals, submains, mains, and then it will be the trunk and outfall sewer. So outfall sewers and trunk is nothing but what, as and when the length is increased, right? So from the nearby houses the more quantity of sewage is going to get add up into these pipelines. So that's why here the size will be much smaller, and as and when it moves towards this end the size is going to become larger. So at the size of these sewer lines will be maximum at the outfall point. So outfall sewer in the sense what, the point of disposal where you are checking out, so the size of that sewer will be much more. So horseshoe shaped sewers or semicircular sections are used for large sewers with heavy discharges. So whenever you want to have more discharge, that is usually at the end of that disposal point, so there you can prefer the horse shaped or semicircular sections which are going to be there. Next we have rectangular or a trapezoidal section is used for conveying storm water. So for conveying this runoff water, okay, where it is not that much polluted and it will be available only in the rainy season, for those things you can prefer the rectangular or trapezoidal sections. So other sections of these sewers have become obsolete due to the difficulty in construction on site and non-availability of these shapes readily in the market. So another few more sections what we have shown. So initially they used to build it, so even I'll show you some of the photographs. So that point of time you can imagine how they would have looked at. Okay, but now because of the modernization, so other sorry, okay, what I can say, conventional sections which are rarely available now have become obsolete, so no one is using them. The reason being what, those are not readily available for the public to utilize or for the persons to construct. Okay, you can check out, these are nothing but the various shapes. Okay, so the first one is egg shaped, standard egg shaped sewer. So here you can check out, so the bottom diameter will be d, again the top diameter will be 2d, so this d can vary. Okay, so this is the actual photograph of that particular sewer. Okay, so here whenever you can check out, so these are made up of bricks. Okay, the material used over here is bricks, and the shape of that sewer is standard egg shaped sewer. So all these concretings will be there. So since you can check out, even though the total flow capacity is more, because the entire section you can see it is more, but since we have a smaller section diameter at the bottom, so the velocity of flow, minimum velocity of flow can be maintained and self cleaning velocity can be maintained. So that's why here this will not allow for the any settlement of the sediment, so that is an advantage over here. Okay, so here even you can see this is a standard circular shape which is available. So from this lateral, again it is coming to the main pipe where the diameter or the section is quite large. Next one we have is new or modified egg shaped. So again the shape is similar, but here instead of that D, here they have even reduced this diameter at the bottom. So as and when you reduce it, the advantage is what, here you can have the cleansing velocity that can be easily maintained over here. And here you can see three ways of materials also. First one is brick, which is exposed. So as I was talking earlier, so to this, if water or sewage gets in contact, so these bricks can easily absorb them. So in turn, it can exfiltrate them on the outer side. Along with that, you can see this is nothing but a concrete finishing which is there. So even here the resistance will be more. Okay, and here you can check out there is some kind of lining which is available here. So this is quite smooth. The hydraulic efficiency of this will be higher. Here the hydraulic efficiency will be lower. The reason being it is quite abrasive to the touch or movement of liquid. And here also, since it is quite abrasive, or else it causes some resistance to the flow, here also the hydraulic efficiency will be less. Okay, so these are the egg shaped sievers. Now next one is horseshoe shaped sieve. So here you can check out bottom is quite flat, but the top portion is semicircular. Okay, so you can check out these kind of things. So here the bottom is flat, so it is easy to construct, whereas the top surface is circular. The reason behind this is what, the force which will be acting on top of this can be easily distributed to the sides since we have this horse shaped section. So this is the actual picture, and here also you can check out the, it is made up of with some kind of exposed material. Okay, so that may be a brick or a concrete or anything. So you can see these particular materials which are there. And even these things which are seen over here, you can check out, right? So these are nothing but to safeguard against the force which is on top of this particular sewer because of the backfilling. So these will provide like a bracings. Okay, this will provide like a bracing to help that sewer material or a sewer shape to withhold the forces that are being acted from on top. Next we have parabolic section. So you can check out, so again the bottom is quite curvy and on top we have this particular shape. So this is nothing but a parabolic section. So I don't have a actual photograph to show you, but this is how that parabolic section will look like. Next we have elliptical section. So the curvature here is quite lenient when I compare it with the previous one. So this is nothing but that shape. Next we have rectangular sewer that you can check out, and here also you can see one important bit is these corners what you are seeing, those are not sharp as it is there on the outside. Reason why they are not sharp is whenever you have such sharp ends, so there is a possibility of sediments are getting settled down. And with the basic hydrological and hydraulic analysis what you have studied, so usually wherever there are sharp edges, so eddy currents are going to form. So eddy currents, whenever they form the turbulence in flow, and as and when the turbulence is more, your losses are going to be more. So that's why, so inside they prefer to have a smooth curved surface for the sewers to be there. Next we have U-shaped section. So it is exactly opposite of I can say horseshoe shape, because in horseshoe bottom we had flat and on top we had the curve. So here it is exactly reverse of that. So again based on the different kind of conditions we can even use the U-shaped sections. Next we have semicircular section. So basically it is a what I can say based on the size of that we can have the semicircular section built up. And the last one is basket handle section. So these are all basically what I can say quite typical shapes which are available. So usually we will not able to see these things, but here why these kind of shapes are required, I'll try to explain it. So basket handle section, you can check out, this is the lower portion, then we have some offset, then we have this circular shape over here. So if you are in the outfall sewer, okay, that is at the end of disposal, so at that point of time huge quantity of sewage can enter into these sewer pipelines through various directions. Okay, imagine this is your main line. Okay, so this is the plan, okay, for this section. And to this, imagine there are n number of pipelines or laterals which are collecting the sewage from various areas, and they are actually coming into this particular point. So at that point of time, how I can explain this is, so these shapes will help us to add up over here. Okay, so this bottom portion is where the sewers can enter, or even from the top portion the sewers from the laterals can enter, and that sewage can be entered here, and the entire contents can be taken from one point to the another point. So only condition is what, here we need to make sure that the entire system should have the reduction in elevation, so that there will not be any clogging of these sewer lines, and also the smooth flow of that sewage because of the gravity that should continue over here.